Hello everyone! Let's continue to solve for differential equations. This time I will be discussing inexact differential equations and how to solve for its solution. So I hope that you will stay with me till the end because I will be discussing only the necessary parts. So let's get started. So how do you know that it is an inexact differential equation? So we have m as a function of x and y, and n is a function of x and y also. And we have a differential equation of this form, m dx plus n dy, if it satisfies this condition such that your partial derivative of m with respect to y is not equal to the partial derivative of n with respect to x. This makes this differential equation inexact. Right? We have already discussed exact differential equations from the previous video. But there is a way to make this differential equation exact, and that is by getting the integrating factor v, which when multiplied to this inexact differential equation, it will make this dE to be exact. But the question now is how to get for the integrating factor v. So actually, there are three cases for that. Case 1 is when you subtract those partial derivatives m minus n and divide it by n, or multiply it by the reciprocal of n. If the resulting function is a function of x, or all the variables that you can see after this process are all x, then your integrating factor would be a function of x also, which is equal to e raised to the integral of f of x dx. But for case 2, you subtract again those partial derivatives, but it would be partial derivative of n with respect to x minus m with respect to y, and then multiply that with 1 over m. If the resulting function is a function of y, or all the variables that you can see are all y, then your integrating factor would be v would be a function of y also, which is equal to e raised to the integral of g of y dy. But there are also times where your v is a function of x and y, and that would be for case 3. If v is a function of both x and y, then your v would be equal to x raised to m, y raised to n. How to determine for m and n? So first is you multiply your functions m and n with x raised to m and y raised to n. So you multiply functions m and n from your inexact differential equation with x raised to m and y raised to n. And if you get that new m and that new n, you differentiate those using these conditions. And with this equation, by algebra, you can solve now for m and n. And what do you do when you get the integrating factors or integrating factor v? So again, multiply v to that inexact differential equation, then solve for the solution like how an exact differential equation is solved. So let's have the first example. Find the solution of the differential equation given by y prime is equal to 2y all over x times the quantity of x squared y cubed plus 1. So really, assuming that we do not know what is the type of this differential equation, the first step is to check for separability, because that is the simplest one. But we know that it is not, so let's just skip that. Then to check for homogeneity. But for me personally, when I solve differential equations, I'd go for separability first, then exactness, because exact differential equations are easier to solve than homogeneous one. Anyway, so much for that. Let's just prove that this is inexact. So let's go back to the equation and let's try to reduce the form into mdx plus ndy equals 0. So we have here dy over dx is equal to 2y all over, I'm going to distribute that one, that would become x cubed y cubed plus x, so that it will become this will become 2y dx minus x cubed y cubed plus x dy equals 0. Then we know what is the m and what is the n. Now to test if this is exact, then what do? Solve for the partial derivative of m. If this is dx, then my partial derivative would be with respect to y. So that's how I remember it. That is dx, differentiate that with respect to y, and then if it is exact, then integrate it with respect to x. So I will differentiate 2y with respect to y, and the derivative of 2y is 2. Am I right? So let's solve for the other one. Wait for a while. For the partial derivative of n with respect to, so if that is y, differentiate that with x be equal to the partial derivative of, please do not forget the negative one, with respect to x. Now what is the derivative of negative x cubed y cubed? Since this is with respect to x, y cubed is considered constant, so this would become, separate first the constant, it would be negative y cubed, then the derivative of x cubed would be 3x squared minus 1. Okay, so it's obvious that this one is not equal to this one, therefore they are inexact. Okay, so what to do next? We have to solve for the integrating factor v. Let's try case 1. What is case 1? Okay, so we will recall, so that is nmn. Okay, nmn, and let's try to see if all the variables that will be present will be x. So nmn, case 1, let's try for case 1. N mn mn, and these are partial derivatives. We know that it is with respect to y, and this is with respect to x. Let's try to see what is our n. Our n is this one, negative x cubed y cubed plus 1. So 1 over negative x cubed y cubed minus x. I'm just distributing the negative there. And what is our this one? That is 2 minus this one. Oh, negative 3x squared y cubed minus 1. That would be equal to 2 2 minus this one, that will become this just simple algebra. So 3x squared y cubed. Positive, because negative times negative is positive. The negative times negative 1, that would be plus 1. And 2 plus 1, that would be plus 3. All over negative x cubed y cubed over 3. But I can factor out here 3. I can factor out here 3, that will become 3 times x squared y cubed plus 1. And for the denominator, I can factor out negative, why am I writing it 3? Sorry guys, it's not 3. That is x. And for the denominator, this is x. I can factor out negative x. And that will become x squared y cubed plus 1. This factor will be, this factor will be cancelled out. Okay. So that the remaining will be equal to negative 3 over x equals. So we will now know what is v. For case 1, now as you can observe, when we do this process, the result is a function of x, or all the variables that you saw are all x. Therefore, our integrating factor v would be equal to, this is case 1. Case 1 guys, this is case 1. And our integrating factor v will be equal to e raised to negative 3 over x dx. And that would be equal to e raised to, what is the integral of negative 3 over x? That is negative 3 ln x. Applying laws of natural logarithm, guys, this will become e raised to ln x to the negative 3. And e raised to ln, then that makes it x cubed, or x to the negative 3. So this is our integrating factor, and we're not done yet. We just solved the integrating factor. We need to multiply this to the original differential equation. But let us use this modified one, the mdx and the ndy. Okay, now let's multiply v to this inexact differential equation. This will become 2x to the negative 3 dx, y dx minus x to the negative 3 times x cubed y cubed plus x dy is equal to 0 times x to the negative 3, that still be 0. So our new exact differential equation will be minus x to the negative 3 times this one. It will become y cubed plus x to the negative 3 times x, that would be x to the negative 2. So actually, we are just simply multiplying something to the differential equation, but we're not changing it, so that this will become exact differential equation. Now, let's try to see if this is really an exact differential equation. So, our new m will become this one, and our new n will be this one. Okay, so let's try to solve for partial derivative of m with respect to x. Oh no, y. Which is equal to the partial derivative of what is our new m? This will be 2x to the negative 3y. 2x to the negative 3y with respect to y. And the answer is y. So x to the negative 3 is constant. We will separate that. That will be 2x to the negative 3. And the derivative of y with respect to y is just 1. Now let's try to solve for n with respect to x. This will be, I'm going to distribute that again. Negative y cubed minus x to the negative 2. And this is with respect to x. With respect to x, which is equal to, so x with respect to x, this is constant, this is 0, and the derivative of negative x to the negative 2, what will be the answer? So power rule. Power rule, this would be negative 2 negative times negative 2 raised to x times x raised to negative 2 minus 1. Okay, negative 2 minus 1, that would be negative 3, or this is equal to 2x raised to negative 3. So can you see, we are multiplying something, x to the negative 3, to both sides. Therefore the equation isn't really changed, but because you multiplied x to the negative 3, this new differential equation that we have, this one, that is already an exact differential equation. So you can see, partial derivative of m and the partial derivative of n are equal. No? This one. They are equal. Now, what's the next step when we solve for exact differential equations? We will solve for f prime. We are solving for f prime. What will be our f prime? F prime is the derivative of your new m with respect to x. That is equal to, what is our new m? 2x cubed to the negative 3 y with respect to x. And the answer is with respect to x, therefore y is constant. So let's separate that first, 2y and the derivative of x cubed. Power rule again for integration, that would be x raised to negative 3 plus 1, so that would be negative 2 over negative 2. That makes it negative y over x squared. Is that correct? Are you with me? So for f prime prime, f prime prime will be equal to the integral of your n. Since n is dy, so when you differentiate with respect to x, but when you integrate, that would be with respect to y. And that would be equal to negative y cubed plus x squared, x to the negative 2 with respect to y, which is equal to, so what would be the derivative or integral of negative y cubed? That would be, is that correct? Negative y cubed? Yes. So this is negative y to the 4th over 4, power rule, plus or minus, distributing that, that would be minus, what would be the integral of x to the negative 2 with respect to y? So therefore this is considered constant, right? So let's separate that first. And the derivative integral of 1 with respect to y, that is simply y. or this is equal to negative y raised to 4 over 4 minus y over x squared. So now we have our function, our r as a function of x and y, which is equal to negative y over x squared, our common terms of both f prime and f prime prime. So that we have the f as which is equal to f prime union f prime prime, which is equal to negative y over x squared minus y to the 4th over 4, and which is equal to c. That is our solution. Okay, so simplifying this, let's multiply both sides by what? Oh, I can't see my pen. 4x squared. So this will become, multiply both sides by negative 4x squared. So this will be 4y plus x squared y to the 4th, is that correct, is equal to negative, so let's just do this, negative 4cx squared. But like I've told you, this one, this is just simply c. Therefore, our final solution would be 4y plus x squared y 4th is equal to cx squared. Okay, so that's it for the long solution of solving inexact differential equations, and that is just for case 1. If you want to proceed to case 2 and case 3, then watch my next video. Thank you for watching. Bye.